Square roots and irrational numbers. Why does nobody talk to circles? Because there is no point. Today's lesson is on square roots and irrational numbers. We're going to find and estimate square roots and to classify numbers as rational or irrational. The Indiana Academic Standard is 7.1.6. The vocabulary. A perfect square is a number that is a square of an integer. Examples would be 4, 9, 16, 25, 36, 49, 64, 81, and 100. Finding a square root is the inverse of squaring a number. For example, the square root of 100 is 10. An irrational number is a number that cannot be written as a ratio of two numbers. All of you are familiar with a rational number. That is pi. Pi is an irrational number because it is a decimal that does not repeat and goes on forever. It can't be written as a ratio of two numbers. Pause the video if you need more time. Example 1. Finding square roots of perfect squares. We need to simplify the square root of 121. This symbol is called the radical sign. Some people call it the square root symbol, but it's technically called the radical sign. When we see this, we're trying to figure out what times itself is that number. Well, 11 squared equals 121. So the square root of 121 is 11. If we shaded in these squares over here, if you shade in an 11 by 11 square, there would be 121 squares shaded in. Now, we're not going to be drawing squares on our homework to try and figure out how many or what the square root of something is. We will be using our calculators, so you need to find the radical sign on your calculator. For some of you, you're going to enter the radical sign, the number, and then hit the enter key or equal sign. For some of you, you'll enter the number and then hit the radical sign. You need to play with your calculator and figure out how to use it. We'll talk about it in class and make sure in class that you know how to use your radical sign on your calculator. Pause the video if you need more time. We're not going to do any estimation. So what I am going to have you do is practice doing this on your calculator. Take the square root of 68, and we are going to round this to the nearest tenth. So try taking the square root of 68 and writing it to the nearest tenth. The square root of 68 rounded to the nearest tenth is 8.2. Don't worry if you can't figure out how to use the symbol on your calculator. I promise in class we'll go over it. Keep in mind, rational numbers are numbers that are whole numbers, they're fractions, they're decimals that either terminate or repeat. So if you get a decimal that doesn't terminate, it doesn't end, or it doesn't repeat, that's when it's irrational. So let's take a look at these. 3a. A is the square root of 121. That's 11. That means that a square root of 121 is rational because that is a perfect square. 121 is a perfect square. B, the square root of 30. It's irrational because 30 is not a perfect square. Also, if you would take the square root of 30, you're going to get a decimal that goes on forever and never ends. C, 20.5167. That's rational because it's a terminating decimal. It's a decimal that ends, so it's rational. And D, 29.2992999 ... It's irrational because the decimal doesn't end and it's not repeating. There's a pattern, but it's not a repeating pattern, so it's an irrational number. Pause the video if you need any more time to copy down this part of the notes. Don't forget to write down any questions that you might have. I know that rational and irrational are a little bit confusing, but I think once you get what these terms mean, you'll be much better off. Number 1A, the square root of 64 is 8. 1B, the square root of 81 is 9. 1C, the square root of 225 is 15. Number 2, suppose Juanita bought 80 tiles to tile a floor. They measured 1 foot each. Use the formula for the area of a square to estimate the dimensions of the floor. Well, we're going to need to take the square root of 80 to see about how many feet that would be. It comes out to about 9, because the square root of 81 would be 9. So the dimensions of the floor is about 9 foot by 9 foot. Number 3, identify each number as rational or irrational. The square root of 2 is a very long decimal that never ends and goes on forever, so it's irrational. 3b, the square root of 81, that would be 9. Since that's a whole number, it's rational. Letter C, 0.6 with a bar notation. That would be a repeating decimal, so it's rational. And number 3D, 1 2/7. It's a fraction, so it's rational. Pause the video if you need time to copy down any part of these notes. Don't forget, tomorrow in class we'll go over any questions you might have, so make sure that you jot them down as you're thinking of them.